slope today. Slope. Now, I do believe yesterday we began discussing, if I'm not mistaken, the notion of a rooftop and how different roofs are slanted different ways. Therefore, those are good examples for us of lines that have different slopes, right? And we had, in fact, now that I think you guys can see my screen at home, hopefully you can. We had talked, let me scroll back up to this slide right here. We had talked about how slope was calculated using rise over run, or delta y over delta x, or y2 minus y1 over x2 minus x1. If you don't already have it down, please, 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 what is in black right here on my screen, I want you guys to have that in your notes, okay? Absolutely must know slope is rise over run, slope is delta y over delta x, slope is change in y, y2 minus y1 over change in x, x2 minus x1. This right here is our slope formula. Especially this part right here. This is how we're going to calculate the slope between two given points. Okay, it's a comparison of the vertical change over the horizontal change. It's a ratio, a comparison. All right, I use this letter M. I did not mention this super impressively yesterday, but the letter M is the letter that we use to stand for slope when it's in slope-intercept form. So this y equals mx plus b form that you guys are now familiar with, okay, that M is your slope. So for example, if I said y equals 1/2 x plus 5, 1/2 is the slope. Every step you take up, you would take 2 to the right. Every step you take up, you would take 2 to the right, and so on and so forth. Okay, so rise over run, keep that in your brain, and we're going to calculate some slopes today in our first example. All right, oops. All right, so if you're ready, I'm going to give you 2 points. I'm going to show you how to calculate the slope between those 2 points. All right, here's our first point, 2, 7, and here's our second point, 3, 5. Okay, so 2, 7, and 3, 5. Now, the very early on, kind of the primary way of doing this is to visualize it, to just see what's going on. So in other words, to plot those 2 points out is a smart idea very early on. Both of these points are in which quadrant, Alex? Cano. All right, try again. Everything's positive, so we're moving right and we're moving up. What's that top right-hand quadrant? No, sirree, Bob, it is not the second. From our notes yesterday and the day before, we talked about how that right there is the first quadrant. Check the screen right there. First quadrant's top right-hand corner, okay? So when we are applying these points, I'm going to go 2 to the right. I'm going to go 7 up. 5, 6, 7. That's going to be my first point. And then we're going to go 3 to the right and 5 up. Oops, that's going to be my second point. I'll do my point in red here. So this line, if I were going to connect the dots, this line is kind of going down into the right, isn't it? James? Do you have a hand up? I'm just stretching. Okay. My peripheral vision, I thought I saw a hand up. All right, there we go. Sometimes I have trouble drawing straight lines with this stylus, but that one's not too bad. It's going down into the right. Now, one of the things that I want you guys to start picking up on is that as we move from left to right, a line that is going downwards is going to have a negative slope. It's okay for a slope to be negative. Okay, it connotates the direction in which the line is pointing. As we move from left to right, if it's pointing down, that's a negatively connotated direction, so that slope would be considered negative. Let's see how we would determine that slope, okay? What's the rise, class? How much is there in delta y? A change of? I see 2 right here. This side of my little triangle. 1, 2. That delta y right there would be 2. What's my delta x? What's my change in x? Good, it's 1. All right, so delta y, remember that means change in y. See if I can get my pen to slide this over a little bit. There we go. Delta y is my change in y. Visually speaking, that's a change of 2. Okay, And visually speaking, my delta x is a change of 1. So we would say that our slope here, m, equals negative 2 over 1, or just negative 2. Why is it negative again? Because it's going down and to the right. Now, that's the visual way. That's kind of like your first stab at looking at how to calculate the slope. What's one of the drawbacks, Quentin, to doing that approach every time? All right. What do you think there, Mossy? Why would I maybe not want to use this approach every single time I calculate slope? Well, that is true. Sometimes the line might go up, but that's not necessarily why I wouldn't want to. I mean, how about this? Perhaps I've asked that question prematurely. Let's look at it the secondary way. Let's look at it using just the formula, okay? So when I say just the formula, and remember your formula, m equals y2 minus y1 over x2 minus x1. Now let's watch and see what. Okay, so if I want to calculate my slope here, y2 is 5, y1 is 7, x2 is 3, x2, 5 minus 7 is negative 2, 3 minus 2 is 1. Wham, bam, thank you, ma'am. Compare the two approaches. Which one would you prefer and why? And in the air, Jake. That's what I'm getting at. If you didn't hear that, Jake said, man, I would prefer the one on the right because the one on the left took longer. And you're absolutely right. If we take our time to draw it out every single time, we'll get them right, but we'll run out of time. Okay? But if we commit to memory our formula and we practice using our formula, what's nice about that is that it doesn't take as long. And we don't get a good visual representation of it, but that's okay. It doesn't take as long. We can calculate the slope very efficiently that way. Now, one of the neat things also, by the way, about our slope formula, did you guys notice which point I called x2 and y2? Which one was it? 2,7 or 3,5? 3,5. I called it 3,5, but it really doesn't matter. Okay, I don't know if you guys noticed that or not, but look, if I had considered my first point, if I had said, well, let's just do 7, I'm going to try and be consistent with my color here, 7 minus 5 over 2 minus 3. That's going to give me 2 over negative 1, or the same value. So in your notes, write down, it really doesn't matter which point you call your second point and which point you call your, quote, first point. Because in green there, look, delta y and delta x could be calculated using that way if we wanted to talk directionally. The first time we did it, we went down and to the right. So we considered the top left-hand point, we considered that to be our first point. But we could just as easily have considered it the other way. We could have gone up to start with and to the left, right? When we go down, that's a negatively connotated vertical direction, isn't it? So when we go down, that's where we got that negative 2. And then when we move to the right, that's where we got positive 1. Here we moved up, and that's a positively connotated direction. So that was the positive 2. But then we had to move back where? To the left. And that was that negative 1 as far as directions go. Okay, we're not saying distance is negative. We're saying that we move in the negative direction. And so that's the discrepancy between having the negative be up top and down at the bottom. Okay? Any questions over y'all's first example of finding slope? Okay, should be a real straightforward, real easy process. Can I give you a couple points and ask y'all to find the slope now? Tiago, you think you can do it? Yes, sir. Attaboy. All right, here we go. So here's y'all's points. Negative 5, 1, and 7, let's say 7, negative 2. We'll do it that way. All right, find the slope between those 2 points. I'm going to kind of mill around the room here and see how you guys are attacking this problem. Use whatever technique you want. I feel like one of you guys was supposed to remind me about something. Maybe like delta math or something like that. Anybody email me asking me a question about delta math? Yeah. Have we talked about that yet?
Not no yet. No, sir.
Okay. Daggum, I knew I was going to forget that. I thought I should have done that yesterday. After this example, remind me to remind me what we're talking about because y'all are going to have some more delta math practice. I think I gave you some last night that's due tomorrow, right? And then I'm going to give you some more on easy stuff, finding slope, like what we're doing right here. All right, now as I walked around the room, I saw several people using the formula, saw several people making drawings out. So we're trying a little bit of both techniques, okay? You got to do you. You got to do you. What that means is figure out what works for you and get good at that, okay? Now, for those of you that were graphing this out, okay, so like Daniel, what quadrant would my first one go into? Thompson? I don't see and I don't hear Daniel, so maybe I'll call on Nate. Nate, what about you? What quadrant would our first point go into?
Quadrant 2.
Aha, there you go. Okay, just took you a second. There you get that mic working. Not a boy. All right, so we're gonna go 5 to the left. We're gonna go 1 up. All right, and then Jack, maybe how about the quadrant for the second point? What do you think, Jack? Nice and loud.
Go quadrant 4.
Yeah, 7 to the right, 2 down. Now these 2 points are real far apart. It's gonna be interesting. See if I can make my line straight. Nope. Try that again. All right, that's not too bad. All right, so those are real far apart. So my triangle is going to be rather large, but that's okay. What's my delta y? Yes, sir?
Can we still simplify?
Always. If you didn't hear that question, he said, do we still simplify? Absolutely. Always, 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 always. That's why I'm drawing this one out, by the way. The 2 points are pretty far apart. What was the delta y? What's my change in y here? Just visually speaking. All right, so it's a change of 3, and we could connotate it negatively if we move down. And then all the way to the right, that's a change of what? 12. Now, if I think about rise over run, 3 over 12 would need to be simplified. Now, this one's going down into the right again, so that slope is going to be negative. So I would say, all right, my slope here, m, equals negative 3 over 12, also known as negative 1/4. Now, that's the reason I wanted to draw this one out. Again, this is kind of a long way around the barn, but it's a great visualization for simplifying your slope. Ow, just hit my podium. Here's what that looks like. Simplifying your slope from negative 3 over 12 to negative 1 over 4 means that I could have actually, watch this in red here, I could have actually gone down 1 and over 4, gone down 1 and over 4, gone down 1 and over 4, and sort of stair-stepped it. You know what I mean? So what we're talking about with simplifying out the slope is we had a big green triangle that actually we could have got the same place by 3 small little red triangles. That's what you're doing when you're simplifying out the slope. Now, of course, if you went the fast way, you use the formula, right? How many of you guys started by saying negative 2 minus 1? Look on your paper, you guys that did the formula. Negative 2 minus 1. Perfect. All right, so here m equals negative 2 minus 1. And then I got to come back and I have to be consistent. This is one of the pitfalls of the formula. Sometimes students get it backwards. So if I start at negative and come over here and say negative 2 minus 1, I need to come back and say, let me come back over there to that same point and say 7 minus negative 5. 7 minus negative 5. And what do you notice that I use there to make sure I keep my signs squared up? Parentheses. All right, negative 2 minus 1 is negative 3. 7 minus negative becomes plus positive. And there we go, got our negative 1/4. And of course, we showed in the last example, it would work the same way coming in reverse. If I had calculated it by saying 1 minus negative 2, and then back over there, negative 5 minus 7, I'm going to get 3 over negative 12, which is the same thing as negative 1/4. So you get it either way you slice it. Whether you start with this as your first point over here at negative 5 comma 1, or you start with this as your first point down there at 7, negative 2. Okay? Y'all feeling pretty good about slope? Now, this is a very basic rudimentary skill. Paul, let's cover up. The skill of finding the slope between 2 points is assumed from here on out. Okay? So in other words, when I go through an example and I say, oh, okay, here, the slope between these 2 points is such and such, you know, you might, in the back of your mind, you might be like, wait a minute, why? This is where we refer back to our notes and we, oh, yeah, that's right. Rise over run, y2 minus y1 over x2 minus x1, that type of things. I'm not joking when I say this. Yesterday in honors calculus, we were finding the average rate of change in a function. We were calculating the slope of a secant line, and they were doing rise over run. And I had a senior, much to his chagrin, in honors calculus, there's a big old mosquito, that did run over rise. Oh my goodness, he did run over rise. And he got the reciprocal of what we were supposed to get. I was like, come on, man. We've been around this. You've had slope for 5 daggum years now. Okay, so this is one of those basic things that you can't forget. All right. Now there will also be times when you're asked to find the slope of an equation of a line when you're given its equation. So let's talk about that. All right. James Jacobs, quiz question. What is the standard form of a linear equation? Don't look at your notes. Oh, I see the fear in his eyes. You got your pass? All right, let's pass that over to Ben Rouse. You don't know. Let's go back to Luke Sublette. Somebody online, anybody at home know besides Jack? I think I talked to Jack already and Nate. Lewis, what is it?
Is it like ax plus bx equals c?
So close, yet so far. Ax plus by
Okay.
equals c. Remember our standard form, ax plus by equals c, where a, b, and c are real numbers. A and b both can equal 0. All right, so that's standard form. All right, give you guys a chance at redemption. Drew Benton, what is the slope-intercept form? This was the one that I had on the screen at the very beginning of class today. It had like y by itself. I'll spot you a y. It's y equals something. Don't have it, Tiago? Y equals mx plus b. All right, very good. Those are the 2 forms that we have so far in our notes. The first one is called standard form. The second one is called slope-intercept form. If you hear me refer to it by those names, you need to make sure you understand which one's which. The one on top is called standard form. And the one on the bottom is called slope-intercept form. Now here's what we want to know from both of these. And then Lewis, we'll get to that example you want to talk about. All right, to calculate the slope in standard form, m equals the opposite of a divided by b. Your slope for an equation, standard form, is the opposite of a over b. You don't have to graph the line out. You don't have to go the long way around the barn and figure out rise over run. If I give you the equation of a line, you ought to be able to tell me the slope at the drop of a hat. If it's in standard form, that slope is the opposite of a over b. If it's in slope-intercept form, woohoo, it's much easier. What's the slope? Just m. Slope is just m. Whatever the coefficient in front of x is, that's your slope. Okay, and in fact, I probably should do a better job. I'll write the word out, slope. So let's say slope equals the opposite of a over b, and down here we'll say slope equals m. All right. Again, if I give you an equation, you ought to be able to come up with the slope pretty dang quick. So like, for example, 3x minus 2y equals, let's say here, chitty chitty bang bang, we'll do 6. All right, so 3x minus 2y equals 6. Can we figure out the slope of that equation? Yes, without doing much of any work at all. Here we're going to say slope equals the opposite of a over b, or just 3/2. Oh, that's so simple. I love that. That's so great. As a backup, as a secondary approach, we could get y by itself. Charlie, what 2 steps would you do to get y by itself here? In other words, to take this out of standard form and to put it into slope-intercept form. Subtract 3x, so we got negative 2y equals negative 3x plus 6. Notice, by the way, I put the x term first. It's supposed to look like that. I put the x term first. I put the x term first. I put the x term first. All right, go ahead, Charlie. Divide everything by negative 2. So we got y equals, bless you. What's a negative over a negative? Positive. All right, so divide by negative 2, divide by negative 2, divide by negative 2. So we got 3/2 x minus 3. So there are our 2 equations. Oh, BT dubs. What's the slope when it's in slope-intercept form? It's the number in front of x. It's the coefficient in front of x. And look at what that coefficient happens to be. 3/2, just like we found it in standard form. Okay? So as a backup, you can go ahead and you can isolate, like Charlie did, you can isolate y. You can say, oh, my coefficient is my slope. All right, any questions about what we've talked about with slope so far today? Anything you guys want to ask? All right, Lewis, you ready?
Sure.
All right, lay it on me. Remind me what our question is.
So on the last, I think there was 3, or you might need to go into Delta Math because I don't remember.
I'm getting it pulled up.
Okay.
And correct me if I'm wrong, but this one was on.
I could do level 1 and 2, but I couldn't
This
figure
is
out
level 3 inequalities with absolute value, right?
Mm-hmm.
Okay, perfect. That's what. There's a quirky. I had a few of my freshmen, so I give you guys all the same work that I give my freshmen. Y'all know that, right? And so these 9th graders, they had a few questions about the user interface on Delta Math for this particular question type, and it's very quirky. And so Lewis, I think, had messaged me or emailed me about it. I was like, you know what, I need to go over this with the whole group. So let's. I think I just went to Delta. You can see my search history right there, can't you? Hello, Delta Math. Ugh. Why is this computer acting so goofy? This could take a moment. All right, now we're cooking. Man, I'm so excited while this is coming up. Yesterday at Kroger, I think I told you guys I've been on a steak binge for the last couple of weeks. Have I told you all that? I've been eating more steak than I usually eat. So yesterday at Kroger, I was getting some stuff for the kids, lunches and whatnot, and they had bacon wrapped fillets on sale. So I scored a couple of those, and I'm gonna cook them up tonight after mountain bike practice. I'm so stoked. It's gonna be delicious. What I have found one of the keys to cooking a good steak is, it's so simple, and yet I used to skip it all the daggum time, is letting it get room temperature before you put it on the grill. You know that? Because if you pull it right out of the fridge, pop it right on the grill, Delta Math, what? Lewis, we might be in trouble, brother. Aha, here we go. All right, we're in business. All right, so we're going to type in inequality. And this was level 3. Lewis, yell at me when you find it. compound. Is it compound inequalities? Yeah, I don't think that was it. Let's do compound. Slowly but surely we get there. Y'all ever just want to take your, hey Will Perone, you ever just want to take your computer and throw it all the time? All right, come on. Here we go. Okay. So compound. We'll try it this way. Nope. Don't. All right, I'll have to go in this way. Thank y'all for your patience. I'm sorry. All right, absolute value inequalities level 3. That's what it's called. All right, absolute value inequalities level 3. Like that. Does anybody know what day the World Series starts on, by the way? It just goes to show you, since the Braves lost, nobody cares.
I think it's today.
I kind of thought so. They made the league championship series is 7 games in 7 days, so I figured they're not gonna pussyfoot around the old World Series. They're gonna get this thing going. How come absolute value inequalities? I mean, am I overlooking something here, fellas? Level 3, maybe? That's right there. All right. Solve the following inequality algebraically. See, Lewis, that ain't what we're talking about, is it? Maybe it is.
What did you say?
Is this the problem type that you're asking about?
It was sort of like that. Yes, sir.
Didn't it have something like, I could have sworn it had like a graphical thing at the bottom, like a number line.
Oh yeah.
Well,
yeah,
whatever.
You like pull the line.
Yeah, I think so. But hey, we're here, so we're gonna go ahead and do this one, and that's just tough toenails. I'll try and find the other one for you. In the meantime, I did send you a link to where I was explaining that user interface. But let's just work this one quickly. Looks like everything divides by 4, so I'm gonna go ahead and divide by 4 right off the bat, just because that's what I want to do. So get absolute value by itself, 2x. What's 8 divided by 4? What's 60 divided by 4? Can I subtract 2 from 15 and get 13? Absolutely. All right, so 13, there we go. Isolating absolute value is the first step. Now it's less than or equal to, so we would use an and statement. So 1 plus 2x less than or equal to 13, and 1 plus 2x is greater than or equal to negative 13. So I'm going to use my little technique there where we rewrite it twice. We change the sign on the other side, and we flip the direction of the inequality. And then we just solve it out. Subtract 1 divided by 2, so we get x less than or equal to 6. And subtract 1 divided by 2, x is greater than or equal to negative 7. And then if here's the issue we would have with our user interface, is getting it to cooperate with this. Both of those are closed marks. X has to be less than or equal to 6 and greater than or equal to negative 7. So that would be our and statement. And if we wanted to put that, we would say X has to be between 6 and negative 7. And I think they're not going to ask me to graph it. They just want me to do it algebraically. So what would I do here? We would say, was it negative 7? X 6, something like that. Woo! And then they'll walk you through the process. There's where they split the 2, and they find those 2 points. It says check numbers. You can check numbers if you want to. All right, so Lewis, I hope that answered your question. If it didn't, we'll figure it out again. But hey, y'all might have seen when I was going through here trying to find that particular problem type, y'all might have seen that you had a homework 3.1 and that not everybody had done it yet. So tonight, let's rock that out. Okay, it pretty much is just talk about drawing lines with a table of values, and then I'll put you a new assignment on here for finding the slopes of lines and find the slope between two given points, and that'll be due on Thursday. So you guys, I won't see y'all tomorrow, but by the time I see you on Thursday, there will be a couple of these little practice assignments that y'all can have to work on. All right, savvy?
Mhm.
Well, thank you so much, fellas. Hope you'll have a wonderful day. Live Jesus in our hearts. I will see y'all on Thursday. Last one in, first one out, sublet. I see how it is.